So for the past few days, I've been slacking a lot for no reason. I was on my phone for hours, killing time meaninglessly scrolling through brain rot content, and at some point it had to stop. So what I did is I removed all the apps from my phone that took majority of my time. It was fine for a while, but eventually I moved on to the next best thing, which was the web. I watched YouTube for God knows how long, and somehow I felt like I was back to square one. Now, I can't delete the browser since my livelihood unfortunately also depends on the web. So I went on the Chrome Web Store to find extensions that somehow regulate my time on these platforms. I did find a few, but that also piqued my interest to understand how extensions work behind the scenes. So that's what I did. I built a basic Google Chrome extension that keeps track of the total time you spend on a web page, and after an hour, it will block access to that web page completely. Now, mind you, it's not that robust and has a lot of missing use cases, but in the couple of hours that took me to build this, I have a decent idea now on how browser extensions usually work and what you'd need to build one on your own. There are a few pieces that you'd need to put together a browser extension, but at the end of the day, these are plain HTML, CSS and JavaScript files with some additional media assets, so that should not be a problem. The first piece, which is the manifest.json file, is like the core component of a browser extension. Its primary use case is to provide metadata about the extension along with pointers to other core files in the extension. So you'll see that I have certain sections in this manifest.json file wherein there is like a pointer to a different file. You can see that there's background.js, there's content.js. So this manifest file has pointers to these other core files in an extension. Now, what are these core files and what do they do exactly? So the two main ones that we'll be focusing on is background.js and content.js. Now, the core functionality of background scripts ideally is to handle events. When I say events, what I mean is anytime you create a tab, you destroy a tab, you even update a tab. So if the title of a tab changes, the icon of the tab changes, or even the URL, if you switch to a different URL inside a tab, that also is considered as a tab update. So whenever these events occur, the background scripts come into play and you can listen to these events and run a few callbacks of your own. These scripts persist as long as the browser is open and the extension is enabled. Now I will go through these files that are present inside this public folder line by line, but for now, all you need to know is what these files are and what they do. So basically anything that's on a higher level and you don't really care about working with the content that's on the active tab, you would use the background script. Anytime you want to work with the actual content though, like for instance, manipulate the DOM tree by adding or removing items or handling user interactions like input fields or full-fledged forms, you would use content scripts. These are obviously not persistent as you'd lose context the moment you close the tab. So these files will have pointers inside this manifest file, as you can see here and here. I skipped a few items at the top here, so let's go through this manifest file line by line. You have a few metadata properties like the manifest version, the name of the extension, the description, and the extension version. The current latest version of manifest is v3, so I'll stick to that. Now these three properties are just metadata for the extension itself. The name of the extension is time tracker. Since I only have one version of this extension and I haven't updated it as of now, it's on version 1.0. And the description just gives a little brief of what this extension is going to do. Then you have the permissions property that's needed in order to use some browser features inside the extension. I'm using these three. The tabs permission allows the extension to access information about the browser's tabs, like their URLs, their titles, and so on. To track the time spent on each website, the extension needs to know which tab is currently active and when the user switches tabs. This can happen only if you have the tabs permission. The active tab permission lets you inject scripts and access the content on the currently active tab. So the action where I'm replacing the DOM with a cat image. So I'm going to do that eventually. When you spend a certain amount of time on a website, so for instance, let's say 1 hour that is currently configured inside this extension. So if I spend more than an hour on a web page, I am going to remove everything inside that web page and just replace it with a cat image. So to do that, I will need this active tab permission, because that is essentially accessing the content of the currently active tab. So yeah, that is the second permission. And the third one is the storage permission that allows the extension to store and retrieve data using Chrome storage APIs. So yeah, then there's this background script that I just covered a minute ago. Starting from manifest v3, you can use a service worker for your background scripts. Service workers have a whole set of features that improve performance and save resources. I have a couple of videos on service workers that you can check out. I'm also attaching this blog post that goes through the differences between background scripts and service workers from v2 to v3. So do give it a read if you want to know more about this. The action key is used to define the properties of the extension's toolbar button. So inside, there's this default pop-up option that specifies the HTML file to be displayed as a pop-up when the user clicks the extension's toolbar button. So say for instance, if you have the Grammarly extension, when you click on that extension, it's going to open a pop-up and show you some features that you can access through that extension. To open that pop-up, you have to point it to a specific HTML file. And in our case, it's going to be this index.html file, which is basically the entry point to our React app. This file right here, it has a div container with the root ID, and this is where our React app is going to be attached. So index.html is the default pop-up that we are going to use. Then there's this default icon that specifies the icon to be used for the extension toolbar button. Then there's the pointer to content scripts. It will match all the URLs, which means any logic that I have inside my content.js file, it's going to run for all the URLs. Anytime I open a tab with whatever domain I have entered, this content script is going to run for that particular domain. You can actually filter down to run this content script only on a specific set of domains, but since our application is going to track the time spent on all websites, we don't really care about the filtering, so that is what I'm going to pass, all URLs. And the file that I'm going to use is content.js, so yeah. Then finally there's this icons key. Now there was already one default icon property at the top here inside the action key. What's different about this icons key then? So this top level icons property deals with different areas where you'd use an icon for your extension. So in the Chrome extensions page or the extensions listing page inside Chrome Web Store, you'd need multiple icon resolutions. That's what gets configured through this icons property. The default icon inside action purely handles the toolbar icon, toolbar button icon. So it has nothing to do with the other places where you are going to display your extension. So your own list of extensions or the Chrome Web Store, over there, it's going to rely on this icons property. So that's the manifest file. Now let's look at the rest of our project. We have three main files to look at. The app file, which is your typical React component. You will find it inside the source directory. The background script and the content script. Let's start with the most familiar one, which is the React app component. I'll go inside the app.js file, and it's pretty straightforward, to be honest. It's a typical React component that renders a list of domains and the time you spend on each domain. So I have the domain name and the time that I spend on each domain. I have a useState variable here that keeps track of an object. This object is essentially a set of key value pairs, with each key being the domain name and the value as the time spent on that domain. Inside the use effect, all I'm doing is calling the fetchTimes function every second. This function uses the Chrome object that's available globally through the Chrome extensions API. So you'll see here that I'm using chrome.runtime.sendMessage, and the name of the message that I'm sending is getTimes. And I run this fetchTimes function once. After that, I set an interval that's going to run for every second. And this interval is essentially running this function. It's using the Chrome object that is present globally through the Chrome extensions API. And all it does is sends a message, getTimes. And whatever response it gets back, it just uses the setTimes function to set that response. And based on this response, we render the list of domains. Now this Chrome object has a set of properties that you'd come across inside this extension at least. One of the properties is chrome.tabs that you'd use to manipulate browser tabs and windows. I'll come to that when I cover this background script section. You'll see here that we have this chrome.tabs object. Chrome.runtime that we just saw inside the app component, it's used to handle extension events. So you can see here that we are sending an event and this is being listened to inside the background.js file. So to handle all these events, we use chrome.runtime. It's also used to communicate between different parts of the application. So if I want to communicate between background.js and content.js, I will again use chrome.runtime. Then we have the chrome.storage key that's used to store, retrieve and track data across browser sessions. Most likely I am using it inside the background script as well. Yeah, you can see here that we are using it here, but again, I'll come back to it. So these are like some of the Chrome APIs that you would come across in many extensions. I'll attach a link in the description that has a list of all the APIs. You can go through them and figure out what you can use if you're building your own extension. Now coming back to the app component. Yeah, as I mentioned, we were using the chrome.runtime.send message to send a message to some part of the extension, which is inside this background script. The name of the event is getTimes, and the response that I get, I'm directly setting it to the state. And just so that I do not get empty content inside my extension, for the first second, I run the fetchTimes function once and then I start the interval. I also have the format time helper here. This basically converts the time that is in milliseconds to hours, minutes, and seconds just to make it more readable. You will also notice one more thing at the top here. I have this comment that says global Chrome. So you see, when you try to build this React app into a production ready bundle, you'll have to run the npm build command. ESLint will pick up an error for the Chrome object that we use inside this use effect, and it will say that it cannot find this Chrome object. We need to tell ESLint that this is a global variable that will be available when the React app is ran in the extension context. When you add this comment at the top, you won't get this error at build time, so that's what this line does. Now let's check the background script. It's again not that difficult. So at the top, I have 4 items that I keep a track of. Every tab in a Chrome has an ID, and all I care about is the one that's active. So the tab ID for the one that's currently open is going to be stored inside this variable. Then I have domain times, which maintains all the domains visited and the total time spent on each domain. Then I have the active domain, which is basically the domain URL for the currently active tab. And finally, I have this start time, which is the timestamp of when the user started spending time on a current tab. So anytime I open github.com or youtube.com, the moment that tab loads completely, that's when a timestamp is going to be attached to the start time variable. This first function at the top is a helper function that extracts the host name from a URL object. So if there's a URL with any kind of params in it, this is going to only extract the domain name. We only care about the time spent on the domain. We do not care about specific pages or query params. So that's what this helper function does. It just extracts the domain from that URL. Before going through this update times function, let's go through these 4 event listeners here. So we have these 4 event listeners. Let's go through them one by one. The first one is onActivated. This is triggered when a tab becomes active. Say if you're working on tab A and you switch to tab B, now tab B is active. But if you come back to tab A, the onActivated will again trigger for tab A. So switching between tabs does trigger this onActivated event. So anytime a tab is active, we set the active tab ID to the ID for the tab that we are on. Active domain is whatever domain we've landed on, and we also set the start time with the value of the current timestamp. But before that, it actually runs this update times function. Now the core functionality of this update times function is just to update the domain times object, which basically has all the domains along with the time spent for each domain, and persist it inside this Chrome storage. That's all it has to do. Update times function is just responsible to update the time that you had spent on the active tab. So anytime a tab is activated, we'll first run the update times function. This function basically just checks if there is a domain already present inside this domain times object. If not, it's going to set its value initially to 0. Let me remove this console log statement. Then all it does is subtract the current time from the start time. So instead of actually explaining you this line by line, let's imagine a scenario. So you open up github.com, the onActivated event listener is going to be triggered. It will run this update times function. Initially everything is null here. So when the update time function runs, when the github.com tab is activated, it's first going to check if there's an active domain or a start time. Since both of them are null, it's not going to really do anything. This update times function for the first time is pretty much redundant. It doesn't really do much. After that, it's going to set the active tab ID. So the tab ID that I have for github.com is going to be set inside this variable. Domain is going to be set to github.com, and the start time is going to be set when the github.com domain is completely loaded. So the moment it gets loaded completely, we have a start time as well. So now we have values for all these three variables. The domain times object is still empty. Now what happens is you open up a new tab. This time inside that tab, you open up youtube.com. So now the activated event again gets triggered. This time the active tab is youtube.com. So before setting these values, it's actually going to run the update times function. The update time function this time has an active domain, which is github.com. We have not yet updated github.com to youtube.com. So we have not yet changed the active tab from GitHub to YouTube. We will be doing that, but before we actually need to update the time that we had spent on github.com. So that is what this function will do. First, it will check if we have an active domain. Yes, we do have it. It's github.com. And we also have a start time. We now map the current time. So the time when youtube.com came into play, that is the current time. So the moment we started github.com to the time we opened up youtube.com, that is the amount of time that I had spent on github.com, correct? So that is what gets saved inside domain times active domain. So active domain is github.com and domain times is an object. So inside this object, there will be a key called www.github.com, and it's going to have the current time minus the start time. Before that, we actually inject a key inside the domain times object, because since we did not really have the github.com domain inside that object, we first need to add it to the object, and we'll assign it to 0. After that, we'll just update the 0 value to the time spent. Now the start time is going to be the current time. So this start time is for the youtube.com tab. So since we've already calculated the time spent for github.com, now the start time is going to be for youtube.com. So that is what we are doing here. And finally, we are just updating the domain times object with the time spent on github.com. So that is basically the flow here. So this is eventually going to reset the values inside the React tab, and we'll have a re-render on our extension pop-up. So that is how this onActivated listener works. Now we have an onUpdated listener as well. So anytime a tab updates, so basically if the title of the tab or the icon or even the domain URL of the tab changes, this is going to be triggered, this event. So this again is pretty straightforward. We do check only when the tab is completely loaded. So there are like different states when a tab updates, and we only check if the tab status is set to complete. If that is the case, we also check if the tab ID is equal to the active tab ID. So this update event is going to run for all the tabs that you have opened up. So you can have like 10 tabs opened up, and the only tab that you actually care about if it updates is the tab on which you are on. We actually really care about the change in the domain URL. So if I'm on youtube.com and I actually update it to like chatgpt.com, we only care about this update event. We do not care about any changes in the icon or the title. So anytime the domain changes, we actually do care about it, because we have to then track the time spent on that domain. So that is what we are listening to here. We only check if the tab ID is the active tab ID, which means if any other tab in the background updates its title or even its domain URL, we do not care about it, because we have already calculated the time spent for that tab. So even if it changes its domain, the time that we had calculated for that domain is already set and it's not really going to affect our objects. So I hope that makes sense. We only care about any updates that happen on the active tab. So let's again go through a scenario here to understand better. We run the update times function anytime there's a change in the tab. So imagine you have youtube.com on a tab and you type chatgpt.com. So this is going to trigger an update. We are on the same tab, so it is going to go inside this if block. It's going to run the update times function, and this update times function is going to first check if there's an active domain. This active domain is youtube.com and not chatgpt.com because the update that we make happens after we run the update times function. So currently the active domain will be youtube.com. After we run this function, it's going to change to chatgpt.com from here. So again, we come back to this update times function. It will check if there's an active domain. Yes, we have youtube.com. It's going to set the current time when we changed youtube.com to chatgpt.com. It will check the domain times object if there's already a youtube.com key. We do have that key. Let's assume that we have that key. So let's assume that we had already opened it sometime before. So if we have that key, it's again going to calculate from the timestamp that we had opened up youtube.com to the current timestamp when we switched from YouTube to ChatGPT, and it's going to add on top of whatever time we have already spent on youtube.com. So it's actually going to add on top of it and not like reset the entry. So we will have like a cumulative value at the end. And if the total time spent on that domain is more than 1 hour, it's going to like replace it with some content. So that is what it does. Then again, it sets the start time to the current time. So the start time is now for chatgpt.com and it updates the domain times object. After that, after actually this update times function is run, we also update the active domain. This will now be set to chatgpt.com and the start time will be set to, I am doing this here and here. So I guess I don't need to set the start time twice. I can get rid of any one of these, but for now we'll just keep it as it is. So yeah, that is how the on update event gets triggered, and these are the things that we do inside the event listener. Then we have the on removed event listener. This again is quite similar to the update event. Anytime a tab is removed, we run the update times function. It's going to update the time that we had spent on the domain which was in the tab that we had removed. It's going to calculate everything and will eventually update the domain times object. This time it will actually set everything back to null. So since we have removed that tab, it's going to set the active tab ID to null, active domain to null, and start time to null. Now imagine that you have two tabs open and you remove one tab. So say you have youtube.com and github.com open. If you remove youtube.com, the browser automatically sets the active tab to github.com. So the one tab that is remaining, it's going to set the active tab automatically to that tab, the remaining tab, github.com. So at that time, this event will again get triggered. So even though we set everything to null, it will go back to this event if we have a tab, and browser will automatically set it as the active tab. So if github.com is the tab that the browser was left with, it is going to set its tab ID, its domain, and its start time. So if there is a tab, then after this on removed, immediately the on activated is going to be triggered and it's going to set everything back. Finally, we have this event listener for get times event. So the event that we are sending from this app.js file, it's being listened to inside this background.js file. So anytime we get a get times event, all we do is again we run the update times function. This update times function this time is not really going to do much since everything is pretty much the same. All that changes is the time that you spend on that particular domain. So if you remember, inside the app.js file, we run this function every second. So what we are doing is we are just updating the time spent on that domain by a second every second. That is what's happening inside this event listener. All it does is run the update times function. This update times function will increment the time spent on that domain by 1 second, and it's going to update the global store. eventually it's going to send back the response with this updated domain times object. So yeah, that is what this listener does. So that is essentially this background JS script. I know it was a bit confusing, but I tried to keep it as simple and as straightforward as possible. The reason why I was explaining you in terms of flows is because that is how you'd understand it better. Instead of me going through each listener line by line, it made more sense for me to explain it to you in terms of real life scenarios. So hope that made sense. Now the final file that we are concerned about is this content script. It again is pretty straightforward. I'll just go through it quickly. So we have this thing here that is basically sending the get times event to get the updated time spent for each domain. Initially, we send a get times event. This get times event is being listened to inside this background script, and get times essentially just sends back the updated domain times. So I do that once and I check the time limit for a particular domain. I'm actually sending the domain times object to this time limit function, check time limit function. But inside this function, I'm only checking it for a particular domain, the domain that is currently active. So the tab that's active, the domain on that tab is what I'm checking for. And I check if the time spent on that domain is more than the time limit. If that is the case, I'm replacing the content and I'm clearing the interval. If that is not the case though, then I actually run the interval as long as the time spent does not exceed the time limit. So this interval will keep running till the 60-minute mark. And the moment you get to that 60-minute mark, it's going to clear the interval and everything will stop. So yeah, that is essentially what this content.js or the content script does. So that is all, at least when it comes to the code side of things. Now we also need to take a look at the extension itself. So to run the extension, first I'll need to build it. So what I'll do here, let me just check if I've actually made changes somewhere. Yeah, I've just removed console log. That's fine. So let me run npm build. So this will actually create a build folder with all the production ready assets. Oh, I had to run npm run build. I already have a build folder here because I was testing earlier. But when I run this, it's just going to replace the contents inside this build folder. So you will have the most recent build. So let's just wait for a couple of seconds. All right, so we have the build ready. Now what I'll do is I'll go back to Chrome, and inside Chrome, I'll open up Chrome extensions. So here I have all my current active extensions and I need to add my own extension. So first thing that I need to do is run this developer mode. So I'll toggle this on and I'll load my extension files. So I'll click on load unpacked, and inside my project directory, I have this build folder that I just created using the npm run build command. I'll select this folder and you see that we have this time tracker extension available now. So I'll go back to github.com. I'll reload this once. And inside my extensions, you will see that I have this time tracker. I'll just open it. And here you can see here that we have github.com as one domain, and the time spent on it is continuously updating every second. So ideally after 1 hour, this should simply just replace everything inside this page with some content, and it should not allow me to interact with this web page any further. So to test that out, what I'll do is I'll go back to my extension, and instead of having the time limit set to 1 hour, I will set it to 15 seconds. So let's just set it to 15 seconds. I will have to rebuild this again. So let me do that. All right, so the build is ready. Now I need to go back to my extensions folder and again import the new build. So I'll select this folder. It has updated. Let me reload this page. We'll have to reload this page because the content script is cached, so it has to be updated. Now if I open up github.com, I mean my extension, you see that it's updating second by second, and the moment I hit 15 seconds, yeah, you can see here that the content is now changed. I have my custom content here on the page, and if I try to reload this, it's again going to update it back to this content. That's because the time limit has already been breached. We've gone beyond the 15-second time limit. So it's not going to let me run my application. It's not going to let me spend more time on this web page. Let me open up one more tab. So if I have ChatGPT open, I'll open up my extension, and here you can see that it's tracking the time spent on ChatGPT. After 15 seconds, it should render my custom content. Yeah, you can see here that it works. So that is essentially what my extension is doing. So yeah, hopefully this brings up my productivity and helps you with building a simple Chrome extension using React and web extension APIs. The code base is in the description. I don't have a reset feature that resets the domain times on a daily basis. Maybe you can add it and see how things work. Also, if you want to run this extension on other browsers, it's probably not going to work because we are literally using Chrome extension APIs, but most likely there is a third-party library called web extension polyfill that probably helps you with using like polyfills for the Chrome APIs that we were using so that it runs on different browsers. I'm not yet tried it out, but maybe you can clone this repo and try it out to see if it works. But yeah, that is it for this video. If you have any other doubts or suggestions, do let me know in the comments, and I'll see you in the next one.